Once you have simplified the architecture, integrated with enterprise LAN, and connected a wide range of devices, the next critical challenge is how you ensure predictable performance and security across all of them. In industrial environments, not all traffic are created equal, right? You can have AGVs and robots that require very low latency and extremely high reliability. At the same time, you may have video applications running on handheld devices that need guaranteed uplink throughput. You may also have sensors, scanners, tablets that are far more tolerant on delay and packet loss. The challenge is all of this traffic is sharing the same physical 5G network. If you treat the network as best effort, eventually something breaks. A video stream can starve in terms of the throughput. A burst of background traffic can introduce latency when you least expect it for these AGVs and robots and so forth. So to address this, we developed our patented solution called Microslicing. Microslicing allows us to create a fine-grained, application-aware slice within the private 5G network. Instead of slicing at a coarse network-wide level, we dynamically allocate the radio and network resources per application on each device. So you can have device classes and different applications with microslices. Microslicing starts at the radio level. Here, which is where we deterministically guarantee the behavior, we have full control of the radio, right? So that's why we were able to implement QoS, Quality of Service Scheduler, at the MAC layer of the 5G radios. We support all the standard 5QI-based QoS profiles, and we map devices or applications into these specific profiles for different policies. So instead of treating the network as best effort, we explicitly define different traffic classes. So AGVs and robotics can be placed into a microslice with strict latency and reliability. Voice or push-to-talk devices, again, can have guaranteed low latency and priority as well. Video applications can be guaranteed certain uplink bandwidth, and so forth. And all the other non-critical devices, such as maybe printers and other devices, can be put as best effort. The scheduler treats the uplink and downlink independently, which is critical in industrial environments where the requirements for video, telemetry, or sensor may be very different for uplink and downlink. Now, the more interesting part is what happens beyond the radio. On the enterprise side, these slices map cleanly into existing LAN architecture. Each traffic class can be associated with a specific VLAN or security segment. That means AGVs can live on one VLAN, and cameras can be on another VLAN, IoT sensors can be on another, and so forth. This gives the true segmentation, not just on air, but also end-to-end, using the same constructs enterprise teams rely on today. And we tie all of this back to the policy framework I mentioned earlier, right? We integrate with existing AAA and NAC systems, and things like Cisco ICE or HP Aruba ClearPass for device identity, authorization, and segmentation can be used this as the same way the enterprise policies already exist today, right? So the result is a zero trust principle extended naturally into private cellular. Every device is visible, every device is authenticated, and gets exactly the network behavior it is entitled to. No more, no less, exactly what you need. And that's what makes the solution enterprise grade. It's not just the QoS, it's the coordinated control across the radio scheduling, LAN segmentation, and identity-based policy, all of them working together, really.